and welcome in this new video of the Robyn tutorial series. In the last video, we have gone through all the Robyn code, we have seen what each line was doing, what it meant, and in the end of the video, we actually started the modeling process. In this video, we are going to see how to output the models to our computer, and then we are going to analyze the outputs of Robyn in order to actually understand what each plot means, what kind of information we can get from each plot, and then in the end, we are going to give you a couple tips on how you can choose the model that best describes the reality. And we are going to talk in detail about this a little later. But before, I will show you what your console should look like once Robyn has finished the execution. I'm going to show you a screenshot because I had this executed on another computer. But as you can see, this is what we left ourselves at the end of the previous video. And we can focus on this line a little more. It's just saying that we started running 5 trials with 2000 iterations per trial. And as you can see, this is something that you will see changing over time. And it's the percentage of completion for each trial. Then it says once the trial is completed, how much time it took for the trial. And in the very end, you are going to see total runtime and the total runtime. So this hasn't yet outputted anything to our computer because this only runs the model, and the model gets saved to this Robyn object, which we declared up here. So on my desktop Robyn tutorial, my Robyn RDS will be the object containing all the model's information. But besides this file, I am yet to see anything on my computer. So to actually get the plots from Robyn, we have to execute these other lines of code. So the output collect Robyn outputs function is what is going to plot the model one pagers and all the other CSV files with information inside. And basically what we are doing here is passing the input collect and the output models object. This is the object with all our inputs inside we set at the beginning of the code. And this output models is actually this variable over here. Then we specify how many output models do we want. So a small number like 1 is going to output the least number of models, which in our case is 5. We are going to see that in a minute. But you can go for 2, 3 or higher just to get even more models because, 5 trials per 2000 iterations means Robyn is actually building like 10,000 models, and you can even want to see them all, but that's a little crazy. So go for smaller numbers like 1 to 2 or 3. That's going to give you a really good idea, in my opinion, of what the Robyn's output are. Then here on CSV output, we can specify Pareto only or all. This is really to start, let's just leave Pareto. We are not going too deep into these kind of options, so Pareto is good. And clusters is a new functionality recently released by Robyn, which basically helps you reduce even more how many best models are given to you by Robyn. So you can set this to true, and you are going to get a smaller set of models. Or otherwise, if you want to have a big picture, you can actually set this to false, and Robyn is going to give you all the models that Robyn considers good in terms of two parameters that we are going to see in a minute. Then the plot Pareto, set this to true if you want to actually plot the models on your computer so that you have the images that you can see. And in the end, the plot folder, which is basically the Robyn object we have defined up there. So you execute that, and you're going to get a folder called like this, which is basically the day and the time you have executed your Robyn model. And this folder is going to be saved inside your path you have defined in the Robyn object. So in my case, for instance, is desktop Cassandra Robyn tutorial. In this folder, you are going to find all the Robyn outputs. So most of them are actually plots that help you go deeper into analyzing what Robyn has found, and the CSV file give you all the numerical information so that you can basically rebuild the plots by yourself and do some more specific analysis. What we are going to focus in this tutorial is the one-pager model. The one-pagers model are these ones up here, and you may have different numbers here. This is just the identifying number of the iteration, or you may have more or less based on your Pareto France variable. In this case, we have these 5 ones, and we are actually going to open all of them up. First, we are going to take a look at the Pareto front. So this gives us a nice idea of how Robyn is selecting our models. Basically, it takes two main variables to define how much the model is describing the reality. It takes the decomposition RSSD and the NRMSE. The NRMSE is basically how much your model is going wrong, is actually predicting wrong the real number of conversions or revenue you are modeling. So if you are doing 10 and the model is actually predicting 8, that's some error, and that's described by the NRMSE, which is a variable which is not just like 10 minus 8, but does some other transformations we are not going to see in this video, but just to give you an idea. And the RSSD is another variable that tries to actually let Robyn understand whether it's going in an unrealistic way, because maybe you are spending 80% of your budget on TikTok ads, for instance, and Robyn assigns an impact to the TikTok ads of 0%. That's really unrealistic, because most of my budget is going in that channel, and Robyn is saying that channel is not driving any kind of sales. So this basically hires the RSSD and tells Robyn, look, you may be wrong, but it's probably not that real. So it's probably not 80% of spend, 0% of impact. Maybe it's a low impact, but not that low. And basically what Robyn does is it builds a model, assigns these two errors to each model, and then it puts the model over this graph. So each little dot you see is actually a model built. And as you can see, model starts to build over here, and then Robyn learns from its mistakes and tries to tune the model in order to get lower errors, and it moves all the way over here. And then as you can see, we still had a pretty high RSSD, but then the model starts to tune to lower the RSSD, and we go basically all the way down here, and this line is pretty much the best models we could get. And as you can see on the right side, the color, the lighter the color, the more iterations are described by these dots. So over here is pretty much the most iterations we got. So this is just to give you an idea of how Robyn selects its models. And what we are saying, what I was saying earlier, and you may have heard this several times over this course, is that we want to find the model that best describes reality. And this is because Robyn may not know your business as well as you do. So what happens is that Robyn can do some statistical calculations and assign a certain amount of impact to a channel, but maybe in a statistical way that's true, but in the real world there may be some variables missing in the model that are not describing that correctly, so Robyn is mistaken, and that can happen. So it's important that, especially in the part of model selection and actually in the model tuning, because you may do one iteration which is not great, so you may want to tune the model a little bit and then actually rebuild the model maybe. And this is something that can happen in the real world, and it's important so that you actually use some of your business knowledge in order to choose and define whether a model is actually good for you or maybe it's missing something. So let's get into the model one pager first. The model one pager is basically this set of plots, which is always these plots in all your models, of course. And the first thing we want to look at, sorry, I was tilting it. The first thing we want to look at is the RSQ train, which is 0.93%, nearly 94. And this is basically the R square, which is the accuracy of the model. So it's how much the model is close to the reality. You can see it here, we are going to see it in a second. But basically, this says that the model is describing 94% of variations in my conversions or revenue. In this case, it's revenue. Then the NRMSC and the decomp RSSD, which are the metrics we talked about earlier. And it basically telling you the value for this specific model. So how you can read this is that this one-pager model is actually describing the iteration number 1,912,2. And all these numbers you are going to see above each plot, but they are basically all the same for the whole model. So the plots are all correlated to this specific model, and the values here are all the same. The values may change from model to model. So as you can see here, the R-square is a little different, and the NRMSC and the RSSD as well. So we are going to see that in a second. But first, let's get back to our first model, and let's go one by one on these plots. So the first one is the decomposition waterfall, and this basically is telling you how much of your sales in percentage is attributed to each channel, to each variable, sorry, because here we have all the variables we have used, not only the channels. So this tells us that 44.69% of our sales are attributed to competitor sales. So what we can tell here is that when our competitor is selling more, we are actually selling more. This could mean that our competitor sells more is because he's spending a lot more in ads. But that traffic is driving to his websites may be actually just creating more traffic for our website too. So our competitor doing more sales is actually driving us more sales. Then there is the trend, which have attributed the 30% approximately of the total sales. And the trend, you can take the trend as basically, okay, if I stop all my marketing activities, I'm still going to generate some sales, of course. And the 30% of my actual total sales are attributed to the trend. So if I will stop doing anything, from today, I will start getting the 30% of what I'm getting today, probably, more or less, of course. Then 9% to newsletter, 5% to TV, and so on. And once you see a negative impact, this means that seasonality, so different seasons of the year, may have an actual negative impact. So seasonality is actually impacting negatively of a 1.78%. And of course, all the percentages that you see here sum to 100%. So if you sum only the positive ones, in this case, you are going to have a little more than 100 because you need to sum the negative one as well, which is going to take this back to 100. Then, sorry, I switched image. Let me get back to this one. Okay. So this one is going to give you an idea of how the model describes the reality. So what you see here is a line that describes your sales over time from 2016 approximately to 2019, which is basically the modeling window, the rolling window we gave Robyn. And the red line is your actual sales. So the sales you really registered in your e-commerce or your shop in general, while the green line is the predicted. So the green line is what the model predicted your sales over time to be. And you can see it's pretty close. It's missing a little, maybe here. It thought the peak will be here, but it in fact was a little later in the time. These peaks were a little underestimated, but most of that is actually pretty well described. And in fact, we are getting a 94% of accuracy over here. Then we have the share of spend versus share of effect per channel with total ROI. And this is really cool because it basically tells you for all your paid channels, so TV, search, print, Facebook, etc. You are going to see in light blue how much of your total spending is spent on that channel. So Facebook, you are spending 80% of your total budget on Facebook, 31 on your total budget on out of home, and 8% on your print, etc. But not only that, it tells you, okay, you are spending this percentage of your spend, but in terms of marketing-driven sales, how much of those sales are actually attributed to the channel? So as you can see here, we are spending a lot on Facebook, but the impact of Facebook is much lower. So we are probably overspending here. That's something that we can take from this graph. And the same goes for out of home. While for all this one, there's a lot higher return in the sense that we are spending less than these two channels, for instance, but we are actually driving a lot more than what's driving Facebook, for let's say. And the red dot indicates the total ROI for each channel. So this is a pretty important graph to take a look at in this one pager model. I switched again, my bad. So let's get back to this one. Sorry. And then this is the response curve. So this is basically the diminishing return curves. You can see here per channel for each color that this is like the response curve for TV. Here you have the spend, so how many money you are investing on that channel, and here's the response. So how much you are, how many dollars are you getting back from that channel? And as you can see here, this is basically sorry for my dog in the background. This is basically, you can see here that, for instance, the print still has a lot to do to give you, because if you spend a little more, you're going to get a much higher return. But then from here on, it's really going to flatten a lot. So it's really going to hit the saturation point more or less here. And the same goes for, you see Facebook has a really pretty flattened curve as well as the out of home, while same as the print, search clicks is actually has a lot to spend yet. Here we are already hitting pretty much the saturation point and so on. And then for the last one, I'll go for this one first, as it's pretty easier to understand. What you can see here is actually is actually the values of your real conversions. And this line is pretty much the function that is trying to catch all the variations in your conversions. And the gray part close to the line is the error that your model has. So as you can see, most of our variations is actually catched by the function, but there are a few points up here, down here, which are really far away from that line. And this means that our model didn't expect, basically, and didn't predict that kind of variations. And this graph is really cool to understand whether we are missing some important variables in our model, because maybe when there is this peak up here, when there is this really down here, maybe that's something that happened like COVID or something like that. And we haven't put that variable inside our model. So the model doesn't know. It cannot know that there was going to be that peak or that downfall. And this is really cool because it gives us an idea whether we are missing out some important variables or not, basically. And in the last one, this is the Adstock graph. And in particular, it says that it's geometric because we, of course, run the model with geometric Adstock. And what it's saying is we are bringing from day one over time the 30% of what we are spending on TV to day two. So let's say I'm spending $100 today on TV and $100 tomorrow. However, not all the people that are seeing my ads today are going to buy today. Some of them may be seeing the ads today and then going to buy tomorrow. What is saying Robyn is that approximately 30% of what I'm spending today on TV, of my $100 spent today, is going to basically have an impact on the next day. So the next day, I'm spending still $100, but I'm going to have this 30% impact from the day one. So what it means is it's like if I'm spending $130. And then if I have this 30% to bring on the next day, that's going to be always 30% from the previous day to the next, and so on. And this is basically, this gives us an idea of which channels convert sooner and which may have a longer time to convert. So investing in TV may result in getting to see an impact in a few days later maybe, while investing on print, for instance, seems to have the shorter term impact. Most of the people that see our ads on print are probably going to buy pretty soon. So this is basically the one-pager model that Robyn plots you and what it means and the kind of information that you can get out here. And however, as we said earlier, Robyn plots several different models because Robyn is not sure which one describes the reality better. Robyn tries to find the best model by assigning them some errors, basically, which is our RMSE and RSSD, but then maybe what it's actually describing is not so close to reality. So what you should do is always take a look at these models and try to maybe what we do. This is our process, so this may not be the best one, but I'm just going to share what we usually do when we are going to select these models. So maybe we may be printing a little more models. Okay, so we may go for 2 or 3 Pareto fronts, which are, let's say, it's going to give us 10 models. We're going to do a little check on R-square and RMSE and RSSD first and see actually which are the best ones. So maybe we are going to end up with 4 to 5 actually best models. And the first thing that we take a look at is the waterfall decomposition. We try to use our business knowledge in order to find the model that actually best describes what our variables are having the most impact on our sales. So I know, for instance, that TV doesn't really have an impact because maybe we have tested a lot on this and we most likely know that TV doesn't have an impact. So if I see the TV as the top one, that's probably a sign that Robyn may be wrong. And that's the first thing that goes in our mind to actually decide whether the model is good or not. Then another thing we do is take a look at the share of spend versus share of effect. And here again, we try to see how much impact is assigned to each paid channel in order to actually, again, try to use our business knowledge in order to, okay, I'm using Robyn to actually find out something that I don't know about my business, but it's important that I try to use it as a support to my business knowledge and what I've already discovered maybe in a year or more of working with a business. So always keep that in mind. Waterfall decomposition, then we take a look at the share of spend versus share of effect and try to understand whether it's realistic for our knowledge. And then a thing that usually happens when you run Robyn on your real data and not some demo CSV data, which is perfect for this kind of instruments to run on, is that the diminishing return curves may look a little unrealistic. You'll get what we're talking about if you're going to use Robyn on your tests, but usually it's not really always that incremental the way you spend money on a channel. So maybe you are already a kind of a big company when you start using a new channel, so you may start spending from a lot, not from 0 to 100 to 1,000, but you maybe start spending like 1,000 a day. So that's really going to make life tough for Robyn to define the proper diminishing return curve. So you may be spending much less on a channel than others. So that's going to, again, make it difficult to define the diminishing return curves well. So that's another thing that we look at, because from our point of view, if Robyn defines wrong or unrealistic diminishing return curves, what happens is then when it has to allocate the budget, it's probably going to make mistakes, in the sense that maybe the curve is really steep and it says, okay, invest a lot more on the channel because, there are a lot of margin, but that may just be a mistake of how the diminishing return curves are are made. So this is mostly the three things that we look at. We look a lot on this graph as well, and basically not much to define which model we are using, but to understand whether our model is having all the right variables inside, or maybe we're missing out something that is important to the business. Then, it's up to you, to the analyst, to the guy working on this, to then choose the best model out of the top 3 or top 5 maybe that you have, and stick with that and try to test that out in the real world. So you are going to get some suggestions from Robyn. You have to test that out. Wait a couple of weeks, maybe wait a month, depending on your business, and then you're going to see whether those suggestions were okay, whether the actual model was correct. So this is pretty much everything for this video. Thank you so much for watching. In the next video, we are going to take one of these models and we are going to use the budget allocator function in Robyn in order to get the budget allocation, and we are going to, of course, analyze the budget allocation plots in order to understand how we can read those graphs as well and what kind of information we can take out from those. Thank you so much for watching, and see you in the next one. Bye.